Hello and welcome to another Jog Vlog session. This one is going to be looking at something which you're going to encounter across paper 1, 2 and 3 when it comes to the exam series, and that is geographical skills. So geographical skills are things that are used, that all geographers should know really, to present or to interpret information that you're provided. So when we talk about geographical skills, what we mean is your ability to read a map or your ability to reference some figures from a graph or describe it properly, or your ability to take some numbers and then process them a little bit to come up with some sort of conclusion. So geographical skills form a really good and important part of geography going forward, especially into A level where it gets a bit more complex. But from a GCSE level, you need to know at least the basics with some of the geographical skills that you're likely to face when it comes to your exams. So we're going to start by looking at map skills, because map skills are the ones that most of us associate with geography, and it's really, really important that you can use maps effectively and you can interpret maps and what they're showing you, as well as be able to use something called referencing and grid references to pinpoint where you should look on a map. So the first and most important map type that I'm going to tell you about is Ordnance Survey Maps, or OS maps. And these maps are absolutely critical when it comes to GCSE geography, because there is absolutely going to be questions that require you to use OS map skills. So if you do not know how to use OS map skills effectively, you will lose marks, and that is not something that you want to do, particularly as the majority of people find map skills fairly straightforward and therefore aren't likely to lose many of those marks. To a lesser extent, sketch maps and atlas maps will appear, but they won't necessarily carry as much weighting. So I'm going to focus most of the time on Ordnance Survey maps. So the first thing you need to know about Ordnance Survey maps is probably the easiest thing about OS maps, and that is symbols. They are often incredibly logical, the symbols that they use for OS maps, and symbols are used just to show you on a flat bit of paper what the land use is. You know, if you were standing there in reality, what would you see in front of you, or where would you be? And there are hundreds of them. The good news for you is that there's always going to be a key. And the key will tell you any of the symbols you see what they are. But it's important for you to maybe have at least a fundamental knowledge, just for the sake of time, in case you need to identify something which is very obviously a car park, for example. If you don't know what a car park symbol is, then you'll have to look it up, and that might eat into your time to actually answer the questions. So it's, you are going to get OS maps at some point, and it could be that you have to, I don't know, locate a specific land use in a city, or you have to locate a part of the city and then use symbols to use as evidence as to why you think it's the CBD or the inner city. So you need to know really what you're looking at. So on the table here are just a number of, was 18 there, of different map kind of information that can be portrayed using a symbol, and what I'd like you to do is pause the screen and just say out loud, or in your head think about whether you think you know what that symbol would be. Okay, and when you're ready, unpause the screen and I'll reveal the symbols. Okay, so hopefully you got something along the lines of these for any of your your guesstimations, really. Some of these are more obvious than others. I think most people know the symbol for parking or campsite, or tourist information, but the things like the woodland might be new to you, or some of the abbreviations like PC, public convenience, you wouldn't necessarily associate that with being a toilet, but that's quite a useful one to know when it comes to looking at maps if you're desperate. Anyway, so symbols, fairly easy thing, and you will have a key, but just be mindful that you may have to identify symbols on an OS map as evidence in an answer. Now, this is the trickiest bit, really, with regards to OS maps, I think, and a lot of the thing where you either kind of get it or you don't. And I think people that don't get it give up too early, because it's so straightforward once you know the technique. Okay, now what you've got here is on the right hand side is one grid square. I know it looks like lots because there's other little lines on there, but try and ignore all the little fainter lines in the middle of this square. So the big box around the outside, that is one grid square. Okay, now this grid square is a very specific number. Okay, the 4-figure reference for this grid square is 1844. Alright, now the reason it's 1844, and I'm sure most of you can obviously spot the numbers at the bottom here, 18 and 44, but you need to know the rules that go around grid referencing so you don't make the mistake, because some people might have thought, well, this one's obviously 1845, or this one's obviously 4418. Any combination that isn't 1844 for this grid square is wrong. Okay, the only grid square that you can see here is 1844. No other combination works. And there's reasons for it. So 3 things that you need to remember, and 3 rules that help you with 4-figure references are these. Firstly, along the corridor. Do it in this order. Okay, you must pick the first number must be from the numbers along the bottom. Okay, or along the corridor. The next set of 2 figures must come from figures that go up the stairs, or northings as we call them, because they count upwards going north. So along the corridor first and up the stairs. Now what that will do is that will stop you giving this grid reference as 4418 or 4518. And so that, because you would definitely start with the numbers on the bottom, okay, if you know these 2 rules. 1844, always that order. But why is it 1844 and not 1944 or 1845? Well, the third rule, and this is probably the most important rule, because this helps you both give a reference but also work out where a location is. You need to work out where the bottom left corner of the grid square is. Now, I'm assuming most of you know your bottom left. Most of you can figure out that this corner is the bottom left corner. And that's particularly important because grid references on OS maps don't, like battleships. Okay, battleships would be where the number sits nicely in the middle of the box. Okay, and this box would be 18 and this would be 44. But that's not how we work in maps, unfortunately. The number refers to a line. Okay, this specific line. So where these 2 lines cross over in the bottom left is where you're going to get your grid reference from. Okay. The rest of these extra little numbers, and the reason we don't put 18 for the whole square, is for 6-figure references, which I'm going to talk about in a second. But 4-figure references, okay, this one, 1844, because we've done the rules, we've used the rules, okay, along the corridor, then up the stairs, and in the bottom left corner. And so 1844 is the only thing that is right for this grid square. Now, 6-figure references are the thing that is where people find that they struggle a little bit. And don't panic about 6-figure references, because if you can do 4-figure, 2/3 of the work is done for you. Okay, and the same rules apply. Okay, as in 4-figure references, you go along the corridor, up the stairs, and you use the bottom left corner for your starting point. Now that's really important, that you still follow those same rules, but it's 6 figures, and so we've got to get an extra 2 numbers from somewhere. Now the extra 2 numbers we've got are where these little numbers come into play that you can see on here. In a map, you're not, or on a map, sorry, a real life one, you're not going to have these numbers written for you. This is just there to show you, okay, to help you out a little bit. But what I would say is that you've all done number lines in maths at some point in your maths career. And if I gave you a number line which had 18 and on this line, no numbers, and 19, so 18 to 19 with nothing in between, and I put on my little cursor here and said, where's that? I reckon the majority of you would say it's 18.5. Okay? And that's really, essentially, how you get the extra figure for your eastings, or your along the corridor, and your extra figure for your northings. And you then have 3 figures for the bottom and 3 figures for the going up the side. So where the red square, or the red circle I should say, annoyingly it's actually between 2, but you'd be able to say 185, okay, because it's roughly 5 across in square 18, and it's 4 roughly 3 up, so 185 443, okay, is where the red blob is. The good thing about these 6-figure references is that you don't have to be exact, because really this is actually right between 5 and 6 along here, so it could be 186 444, and that would still get you the mark, because it's basically the same. Okay, it's so close, and it's an estimate, but you need to be aware of that third figure for each of these sections, the eastings and the northings, to get your 6 figures in total. It's really, really important. So there will be flexibility about what they allow, they're not going to say, for example, 189, because that's miles away from where it would be. But 185, 186, yeah, basically the same, fine. 443, 444, yeah, again, roughly the same. So either any combination of those different aspects would be fine. And again, same applies to the grey square here. 187 or 188 for the first three digits, and 448 or 449 for the second three digits would be absolutely fine as well. But the thing is, they must always start with 18 something and then 44 something. So they are basically the same as the four-figure reference, just with an extra little digit added in. Okay, hopefully that's helped you with six-figure references, and I would really urge you to spend time to make sure you fully understand that and practice it as well, using a proper OS map where you won't have these little numbers to help you. Okay, so a bit of extra practice for you then. What I would like you to do, please, is pause the screen and just in your mind figure out, combining your knowledge of symbols, but also combining your knowledge of four-figure and six-figure references. I would like you to try and give the four-figure reference for the TV or radio mast, the battlefield, and the castle. I'd like you to try and give me the six-figure references for the car park, the campsite, the picnic site, and the church with a tower. Okay, so do that. Pause the screen now, and then when you're ready, unpause the screen. I'll reveal the answers to you, and you'll see if you're right. Okay, so there are the answers that I would have given. Remember, with regards to the six-figure reference, you might get a bit of flexibility. So the car park, which is here, okay, you can see with a P, you could say it's certainly in grid square 16 something, but 1632 is probably the main grid square you'd find it in, because most of the box is in there. But arguably, part of it does go into 1631, doesn't it? But I would say it's probably 164, 3, 4 across, maybe even 5. So 1, 6, 3, 4 or 5 is fine, and 3, 2, 1, 2 or 3 is fine there as well. Okay, because of how big that particular symbol is. So have a check of your answers, make sure you've got there or thereabouts, and when you're ready you can move on to the next part of the session. Okay, so another thing that you can see with OS maps is often you've got these little lines, okay, they're kind of orangey, browny coloured lines, and some of them will have numbers on them, some of the time they won't, and maybe only every 5 or 10 have numbers. And these are contour lines. They're very, very faint, and you might not see many of them on maps in Norfolk because Norfolk isn't very high and doesn't have much change in slope. And that is an indication of what these things show you. That they show you how steep or flat land is. So every one of these lines, okay, every point, if you were standing on this particular point on a map, you would be at exactly the same height above sea level. Okay, so everywhere on this red line, this orangey red line here, my arrow's going around now, everywhere is the same height above sea level. Okay, it's 10 meters above sea level. And you can see that if I put that onto like a little contour diagram, this is what I would be. So I would be standing along this line here, 10. I'd be somewhere around this mountain, but I'd be the same height. No matter where on this line I was standing, I'd be the same height above sea level. Okay, so when you see a pattern of contours like this, where they get smaller and smaller circles, if the number's counting up, you're looking at a mountain, because everywhere around the mountain is getting higher. Okay, and if they're close together, like this side, they're closer together than this side is steeper than this side. This is a much more gently sloping side, because the closer together they are, the contour lines are, the bigger the jump between the distance over a short space of time. Make sense? So when they're close together, contour lines indicate a steep slope, because the jump up to the next 10 meters has got less kind of across distance, so this would make it steeper. When they're far apart or further apart, you can see you've got a longer surface distance to move that 10 meters, and so it makes it less steep. And spot heights or spot elevations can also be listed on the map as a separate little dot, often a black dot with a number that tells you the specific height of that particular point. And the peaks of mountains will often have their highest point listed on a map. Now in Norfolk, you will find most contour lines are very far apart. They're much further apart than these are because we don't have mountains in Norfolk. We've got some hills, and if you were to look near the coast, specifically sort of Sheringham area, and you got an OS map of that, you'd actually see more of these contour lines close together because that's where we get a lot of our hills in Norfolk, if you can still call them hills. So contour lines show points of, sorry about the typo, equal height on a flat map. Because a map is a flat bit of paper, you want to know if, let's say you're going to take Granny for a walk and she's in a wheelchair. The last thing you want to do is take Granny for a walk where you've got a mountain to go up because there's no way. Now, a map would only tell you that if you saw the contour lines first. So that's why they're there, to show you what the land would look like in terms of its height. Okay. Now contours, they can tell you about obviously the shape of the land, if it's flat or steep, which is useful. And spot heights are shown in those black dots. And again, the numbers that appear will give you a bit of an indication as to how high above sea level you might be. But contour lines are something which, again, you probably just need to know, for GCSE at least, if they're close together, it's steep. If they're far apart, it's gently sloping or flat. Okay. Okay, and describing OS maps. Now, this is almost the final aspect of OS maps that I need to talk to you about, because symbols, grid references, and contours are the most specific parts. But when it comes to actually getting given an OS map and describing it, this is something which is also really useful and quite commonplace in geography. So, firstly, you might need to have the OS maps to describe the site of a place, in which case you would look at where the place is, and you would try and include any specific physical characteristics the land has been built upon. So if you think about changing cities, for Norwich, you would see the River Wensum flows through it on an OS map. So you would have to say, right, a site factor is it's got a river flowing through it, the Wensum. Other physical factors might be about how steep it is, which is where your contour lines come into play. The type of plant life you might get there. So is it mixed woodland, coniferous woodland? Is it marshland? Is it grassland? Whatever it might be. All of that will be shown on an OS map with symbols. Situation, where is that place and what's around it? Again, think about both physical and human features with regards to situation. So roads as a human feature, ports, airports, for example, but also physical features, again, other rivers, other things that might be close to it, like a coast, a sea coast, for example. The shape of a settlement is something you can see quite nicely from above, because all OS maps show you from above, and you need to be able to describe the shapes of settlements. So are they clustered together? Are they nucleated around a central square? Are they linear along a line? Do they follow a road or a river or a railway line, for example? And land use, again, that kind of links into the first one, really, about site. How is the land being used? Is there farmland? Is it mainly residential? Housing? Is it factories? All of that will be visible on an OS map. So this is a good example that shows you that. This is Keswick in Cumbria, and Keswick, the site factors, it's got a river that runs through Keswick. You can see it there. It's got, which is the Derwent, I believe. Roads to the north and south, again, they show its situation, and you can name those roads if I could zoom out a bit further. It's got coniferous woodland down here in the southwest. You can see, look, it's got the little Christmas trees on it. And there's a bit of mixed woodland to the southeast, a little bit of mixed woodland to the north and northwest. There's a lake here, again, to the south of Keswick. It's situated on a bend in a river, a meander, which is good, just like Norwich is actually. It's a low crossing point. And up here, this is where you can see your contour line. So up here, you've got a mountain, effectively, and there's a spot height there. The top of La Trigue says 368 metres above sea level, and every one of these contour lines is very close together, and that tells you it's very steep. Okay, this is a very steeply sloping mountain just to the northeast of Keswick. Okay, whereas when you get close to Keswick, the contour lines get further apart, and therefore suggesting Keswick is quite flat. And the fact it's near a river, rivers tend to be quite flat areas because around them they create floodplains. So there you go, that's how you could see it in action. Now, settlement shape, I mentioned, could it be nucleated, linear? This shows you the different kind of patterns you might find. So nucleated settlements are where you've got lots of buildings and they tend to be around a central point or like a crossroads, for example. Linear tend to be built in a line. That's what linear means. Again, a lot often along a road or a railway or a river. And dispersed are like, your really rural areas that are spread apart. So houses that are quite widely spread apart. One or two or three or four houses, quite a few, 100 meters away from each other. That sort of thing. Right. Sketch maps. Now we've looked at OS maps. I'm going to try and link them to sketch maps, because the only ever time you'll use a sketch map, you won't be asked to sketch something in an exam. I just can't see it happening. I've never seen it happen so far, because it takes too long to do a sketch map, a proper one. But you do need to know a sketch map, and the way I could see this potentially being used is in paper 3 for the field work, because you might be presented with a sketch map that someone else has done, and then talk about maybe its strengths or weaknesses to present data. So sketch maps are, you take an OS map basically and you simplify it so you only see the bits you need. Because remember, looking at this is very complicated, and there's no way you need all that information. If you're doing geography fieldwork, you might just need information about the lake, the river, the roads. So why have every single one of these trees in there? You don't need all of that. You can make it much more simplified, and that's what a sketch map is. So if I took an OS map where I wanted to get the rivers, or so the roads, and some key features. So these little things here might be buildings, for example, and I've got just a couple of indications as to what other things are around this area, but I've put only key buildings in here: the village store, the cricketer pub, and the church. Okay, and maybe my house, wherever that might be. So sketch maps need to be to scale. Actually, that is quite important, because they're a sketch of an OS map. They should be roughly, not exactly, but roughly to scale. Okay, so to make something to scale, it needs to be, that distance apart needs to be roughly accurate according to this line, and you must always put a little scale line on a sketch map. So I know that the village store is about 250 meters away from the cricketer's pub. You should also have a north arrow every single time. Luckily for you, OS maps are always northwards at the top of the map as you read it. So if you're using an OS map, you can just assume that north is up. Okay. So the first thing you should do is draw a box to the same size as your sketch, so it goes into the right size, and then include the main human and physical features, so main lines essentially. And once you've done that, you label it, you add a key, okay, and make sure you've got your scale and north arrow in there. Must have north arrow and scale line. Now let me show you what this looks like. Okay, and take note of this. Okay, so if someone's done this and they don't have a scale, and you're asked to analyse it as a bit of information, an easy win would be, let's imagine that wasn't there, you'd say this person doesn't have a scale, so you have no idea where the village store and the cricketer's pub is. This one happens to have a scale, which is good. So let's have a look. Oh no, I'm not going to show you that on in reality. But okay, so these are just the instructions. Sorry about that. So yeah, you would draw a box around the right size, so the same size as your grid square, and then you would just include firstly the major lines for roads and rivers, and then major buildings, and then everything else really just don't need. Get rid of it. Ignore it. So sketch maps, not likely to appear, but something worthwhile and worth thinking about if you were given them as a question to analyse in like a paper 3 section. Now atlas maps. Atlas maps are basically any map that isn't as detailed as an OS map. They often are much more zoomed out, okay, so large scale. So this is the the largest scale map you're ever going to get, which is one of the world. And you should see these lines that go across the world, and these are lines of latitude, some of which you've heard of: the equator, the tropics of Cancer and Capricorn, and the Arctic Circle and Antarctic Circle. And there's other lines of latitude in between. In fact, there's lines of latitude that go all the way up and down the Earth. Now, the key to these lines of latitude, they're not really there, obviously just there as reference points, is that the equator is 0. It starts at 0, and then anything north counts up to 90, and 90 degrees is the North Pole. And south, it also counts up to 90, but it will say S for south. So any lines below the equator will have an S at the end. Any lines above will have an N at the end. Okay, and this degrees thing, 23.5 degrees, just shows us its position away from the equator. How they get this as a degree is the angle it makes. So if you imagine a straight line going from that touches the equator perpendicular, so 90 degrees would be there. Okay, sort of. there would be no angle met there. But as you get further north, the angle of the Earth changes. So at the North Pole, if you imagine that line that I've just imaginarily drawn with my cursor, okay, if I was to draw a line that comes from the North Pole to it, the angle that that line would be meeting the imaginary line would be 90 degrees, and that's why it gets 90 degrees north. This one wouldn't be the same. The angle would be slightly different, and so it would actually be 66.5 degrees. And this just refers to the amount of curvature of the Earth, basically. And the number counts up to 90 because that's the most extreme. All right, so that's latitude. Longitude we don't use as often because latitude appears in our ecosystems topic and our weather hazards and climate change topic. Alright, so you should be aware of it from that. Longitude we don't really use very much, but it's the same as latitude, just going around the Earth rather than above and below the equator. So the starting point, 0, is called the Greenwich Prime Meridian, or the Prime Meridian line. And that happens to be through London in Greenwich, and that's why they call it Greenwich Prime Meridian. So essentially, London is the centre of the Earth in sort of, when we're talking about longitude, it's the middle point. And then from there, everything left of that or west of that has a W, and anything east of it has an E. Okay, which makes sense, when you think about the fact that this goes north and south. So you can actually have figures that go north, west, south, east, whatever, and pinpoint a specific location on the Earth. Now let me show you just a summary of that. So latitude, they're horizontal lines. The equator's at 0, and it goes up to 90 to the North Pole and up to 90 to the South Pole. And latitude lines include the tropics, which links to weather and ecosystems, like I mentioned. Longitude are the vertical lines. The prime meridian is 0 degrees and goes through Greenwich in London. Excuse me. Everything left of the line or west of the line is up to 180 degrees W, and anything east of the prime meridian line counts up to 180 degrees with east at the end. Okay, and these longitude is useful for us as geographers, particularly if you're travelling. So anything to the right or east of the Greenwich Prime Meridian line, you would actually count forward in time. So that's why they say people in Tokyo are so and so many hours ahead of London, because they are further round the Earth than us. So essentially, because of the way the Earth spins, their day starts sooner, okay, and starts earlier than ours. So that's why we know in London, if it's 12 midday, in Tokyo it could be, I don't know what the exact number is, but it could be 8 p.m. that same day, if that makes sense, because of just what bit of the Earth is facing the sun at that point. Okay, so that's latitude and longitude, and this is how you can see latitude and longitude on a flat map to help you. So just to test your skills, I've picked 3 nicely situated numbers, or places, sorry, where places cross: Cairo, New Orleans and Shanghai. I'd like you to tell me what you think the latitude, longitude positions of Cairo, New Orleans and Shanghai are, please. So pause the screen, figure it out, and when you've done, you can unpause the screen and I'll reveal. Okay, so there you go. You can see the 2 lines. You've got the equator and the Greenwich Prime Meridian line. So you've got your 4 kind of quarters of the Earth, I suppose you'd call it. That's the northwest quarter of the Earth. That's the northeast, southwest, southeast. So any number in this square should have something N, something W. And anything in this one should have something N, something E. Make sense? Now, Cairo is here, okay, which is a nice crossover point. So the figures I would give for this one are 30 degrees north and 30 degrees east, okay, in that order, because that's how compass directions are. They'd always start with the north or south rather than east, west starting. So 30 degrees north, 30 degrees east is Cairo. New Orleans over here is 30 degrees north and 90 degrees west. And Shanghai over here is 30 degrees north again and 120 degrees east. Okay, hopefully that's easy enough. Again, these are very rare occurrences. You're not very likely to see these appearing anytime soon. Okay, moving on. Graph skills. So now we've covered map skills or cartographic skills. We're going to start to look at graph skills in general. Now, graphs, there are so many types of graph that you could encounter and that could be presented to you. And what you need to know about graphs, okay, is firstly what sort of one you're looking at. You might need to know how to make them, That's less likely, but certainly how to complete them accurately. So line graphs, you need to know what is a line graph, so be able to complete some data on one, for example. You need to know advantages and disadvantages of them too, so of using them to present the data that's on them. And again, that's useful for paper 3 mostly. And for some, you might need to be able to justify why you might want to use that type of graph, and that links in really with the advantages, disadvantages. Now in this bit, I've got all of those bits, okay, in a summary format, which I've completely taken from someone else's work that they published and put on the internet for people to use, and I've screenshotted it on here. And following that, I've got some practice for you to use, which I've also taken from a skills booklet, which I've totally pilfered. This is an example of how it's going to appear, and you've got everything for each graph you need. I'm not going to sit and dwell on it because you've got it in front of you and you can pause the screen and make notes at your leisure. So this one obviously shows you the name of the graph. It's a bar chart. How would you construct it? Okay, or describe how to construct it. So it shows one piece of data, bars drawn next to each other, blah, blah, blah. Advantages of using bar charts. There's loads of stuff listed. Disadvantages. What you could use instead, or what you could do instead to improve it. Justification of why use that technique, and other things you must make sure they all include. So that links into kind of how to construct it. So everything is covered about bar charts that you need to know on this particular summary slide, which someone else has done for you. So pause the screen, get all the information you need, read it through. If you just want to read through, that's fine. And I'm going to, after 3 seconds, I'm going to move to the next one because there's a few slides with these same format on them. Okay, so this next one is looking at line graphs. Again, how you construct it, when you should use it, what's good practice, justifying why use that technique, advantages, disadvantages. I'll give you another 3 seconds. You can pause it, get all that information, please. Scatter graphs. This one doesn't actually have a line of best fit, but it's got lots of data on there which almost forms a line with one anomaly. So again, same applies. How to construct, advantages, disadvantages, improvements, and justification. Pie charts, same as before, please. I'll give you 3 seconds and you can pause it and get the information you need. Dispersion diagrams, or whisker and box plots. These are a bit trickier. I've never seen one of these appear in geography yet. That said, it is a very good type of graph for certain aspects of the fieldwork element that we have to do. So don't dismiss this completely. In fact, pay attention. In historically, we actually do ask students to do whisker and box plots to measure something called dispersion or spread of data. This has got a lot more detail on it. I wouldn't worry yourself too much, but I don't want you to be completely unfamiliar with these in case they do appear in paper 3. So again, I'll give you 3 seconds before I move on. You can pause it, take as long as you need for this, please. Triangle graphs. We've incorporated these into lessons before, and in the development topic, we looked at this with regards to how India's economic structure changed. And it's a way of showing 3 categories of 100% of something. So it only really could be used when you're looking at population data or economic sector data. But again, 3 seconds, I'll leave, and then you can get your notes. And there's a few others here that are put in a different format, where I've just put advantages and disadvantages that that I can think of for each of them, because they're things that could easily appear. So population pyramids, a couple of advantages and disadvantages, and desire lines, something you probably haven't encountered. Again, it's very rare. You would not likely to see it, but it's not to say it won't appear. Flow lines, we do try and do a bit with flow lines, but again, advantages, disadvantages listed there, and proportional symbols we definitely show you a few times throughout lessons. So again, have a little look at the advantages and disadvantages for both of these, please. Choropleth maps, these are used really regularly in geography, and actually it's arguable that it's a graph skill rather than a map skill. But because it uses data and plots it on a graph, excuse me, it's probably more suited to being called a graph skill. So again, you've got advantages and disadvantages for those, and an example there to the right for population density. Dot maps. It doesn't, again, look like much of a dot map. That's because there's so many dots on it. But dot maps with information about what they are and what they show. ISO line maps, very specialised. Only really going to find these if you're looking at weather hazards and climate change, and even then, probably not going to look at them. So I've just added these in because it was in the resource that I was given as a bit of a just in case. Okay, so again, don't be intimidated by this. You're very, very unlikely to see this, but it might help you understand when you watch the weather next what's going on. Okay, now this is a section where you can actually practice some of the graph or finishing graph skills. So here you can see in yellow, it's got a question that says, study figure 16. It shows the population densities of some parishes in South Devon. Complete figure 16 by using the data in the table below. You will have to complete some form of graph or thing with data. And my biggest annoyance is when students just don't do it and they miss it out because they're being a bit careless. Please be on the lookout. Anytime you see a resource, first thing is just check whether you have to do something and add something to it to begin with, all right? But pause the screen to see what you would do here. You don't actually have to do it and print this off, but pause the screen to see what you would do and how you would complete this particular bit of information. Okay, there's another couple of questions here that, again, from the information I've presented to you already, you should be able to do. So again, pause the screen. One of them is asking you to describe a pattern of population density. So describing patterns on maps, we've covered that. And also another one is for a choropleth map, which is figure 16 still, an advantage and a disadvantage of using that to display the data. So try and be as obvious as possible with what you're saying, because that's all you'll need to do to get marks on this. Okay, I'm going to pause myself for 3 seconds, and then you can pause for longer if you need it. Another bit of practice here. This is a bar chart. Well, it's actually a population pyramid, but which is really just like 2 bar charts back to back. So again, fairly self-explanatory. Pause the screen, have a go. The last bit, which says comment on the age structure, that really is just testing your knowledge of what population pyramids show. So comment on just means refer to which of the biggest sections maybe, and suggest reasons why they might be the biggest sections. So that one, if you don't want to do, that's fine, but that's the kind of thing that kind of goes along with these sorts of questions, as well as just completing it. This one's a really good example of a rose diagram, which is effectively like a compass rose, and it's fairly self-explanatory. It tells you in the information a rose diagram showing some of the results of a questionnaire carried out in a car park in the Malvern Hills. The bars show the direction from which people had travelled to visit the Malvern Hills. Okay, so it's a bit like a desire line type graph. And there are 3 questions that go alongside that, please. A nice scatter graph question for you. This is, again, something that I think is probably definitely worth spending a bit of time looking at, because scatter graphs can confuse people, and people sort of struggle a little bit with them. You can't do it all, and often, again, because this is a video, you're not going to be able to print this out and do it, but you can certainly work out where you think you would put stuff if you want to practice it. It's just better to have that option to do so. And this one is a classic climate graph question. So it's a bar and a line graph all mixed into one with 2 axes, one on the left, one on the right. So again, I'll pause, you get on with it, and when you're ready, unpause the screen. So the final thing I want to talk to you about is the final skill, which again is definitely going to appear in your exam. And in fact, it seems to be appearing more and more regularly in geography exams. But that's good news because the stuff they're asking you to do is really straightforward. So statistical or numerical or number skills in geography, it's not just something that's isolated to maths that you have to learn for maths. Okay, so you need to know them for geography. The good news is you don't need to know quadratic equations and trigonometry and all those things that make maths the challenging subject it is. You need to know some basics. Firstly, you need to know what mean, mode, and median are. I really hope you do, but I know from marking papers that a lot of you don't. So you must know those because, again, they will appear in some form. You need to know what range is. Interquartile range is a bit rarer to appear in exams, but again, worthwhile knowing because it's on the spec. And the one that's the hardest is percentage increase and decrease. Now you can see in brackets, it says, I need my own resources for this. Use UK Challenges task from Challenge 1. This is a note to myself really more than anything to go over this with you in class because this is something which I've recognised as pupils really struggle with. The reason I've left that bracket in is to remind me of that fact, but also because you might have a better way of doing this than maybe I might show you on this. So what I mean by that is your maths teacher has probably had to teach you how to do percentage increase and decrease. And they have probably taught you a technique, and I'm keen not to necessarily teach you the technique that I know because it might be different to how you've learned, and that might confuse you. So it's really, really important that if you've learnt this in maths that you just stick with that one, okay? Unless you really don't understand it, in which case my technique might help you, but you need to do that and speak to me on an individual basis about that. So I'm just going to summarise these for you a little bit. Mean, mode and median are all measures of average, okay, but you will get a different figure depending on what you're doing. Mean is all of the figures added up divided by the number of figures. Okay, so all of the, let's say you how many test scores that students got. You had 10 students and they got a percentage out of 100. Okay, to work out the mean, you'd add up all the test scores and you'd divide them by 10, which is the number of pupils. Okay, that's the mean. The mode is the most common, most common. So the most common figure in a set of data. So if the same set of data, let's talk about test scores, if I had 10 students and they had 20%, 30%, 40%, 40%, 40%, 40%, 50, 60, 70, whatever, then the most common is 40%. So that would be my modal average. And median is just the middle value. When you order your number, or your number from smallest to most, or lowest to largest, the one that sits like physically in the middle. Now if you've got an odd number, that's great because the odd number is the middle number. But if you've got an even number of things like 10 students, it's the mean between student 5 and student 6. Okay, so you would just take those and do a mean. So that's how you get around it if you've got an even number of data. But all of these are measures of average, ways you can create an average figure. Now, here's an example that relates it to geography rather than students' test scores. So look at this set of data for river discharge, okay, amount of water per second. Calculate the mean, mode and median of this information. Okay, so try doing each of them. You should get a different figure. Okay, so mean, mode and median, practice doing those now please. Pause the screen, get it done, and then when you're ready, unpause and I'll reveal. Okay, so the mean of this data is 29.6. The mode is 21 and 24 because there are two the same. So hopefully you put 21 and 24. And the median, even number, is 24. Okay, so when ordered, median value 24. Right. So it's likely, because it's a GCSE exam where you have limited time, you'll only have a small data set to use. So if you do need to do a median, you still could do that quite quickly in a very short space of time. Just double check your answers, okay, to make sure you don't make a silly error. All right, so mean, mode, median, pretty easy, I hope, for you. When it comes to range and interquartile range, that's measuring spread of data. So rather than the average, the middle figure, we're really looking at how far apart the data is from each other. So the range is the basic spread of data, and that's where you just take the biggest number and you minus the smallest number from it. Okay, an interquartile range is much more accurate and a little bit more tricky. So this is where you take away the extremes, which range doesn't do. Let's say one person never turns up to school and gets a score of 0, and then everyone else gets at least 20% or up to maybe 80%. If you included the score of 0, it's going to move your figures, your average figures, down, and your range is going to be a little bit off. So the interquartile range would take out these extreme low scores and the extreme high scores and leave you with a middle range to use instead, which gives you a more accurate range of data. So you calculate the range literally by, you would do it like you would with calculating the median. Okay, so you number the scores from highest to lowest, and then you just literally take the lowest figure from the highest. Okay, so you take the lowest number away from the highest, and that is your answer. For interquartile range, okay, find the median. That's the starting point. Okay, so find your middle number or the middle average number. You then need to imagine your data set is now in two halves. Okay, the first half from 0 to the median is gonna you need to work out the middle number there, the median of that first half, and that will give you what's called your lower quartile. You then find the middle value between the median and the highest number to give you an upper quartile. Okay, and quartile just refers to there being 4, because if you think 0 to the first quarter to half to the 3/4 to the end, it breaks up your data into 4 little quarters, and that's why we call it quartiles. So what you've now got, okay, is a set of data where you've worked out the middle, and you've worked out halfway between the middle and the first bit, and halfway between the middle and the last number. Okay, so you've got quartered data. To work out the interquartile range, all you do is you take your upper quartile away from your lower quartile away from your upper quartile. So it's literally the same as range, except you're discounting anything that's less than the lower quartile, and you're discounting anything that's more than the upper quartile, and that tends to eliminate anomalous results. You know, people that got 0 because they never turned up, as well as people that got 100% who are like genius level. So it gives you a more reliable range than just using the range as a basic format. I've not yet seen interquartile range in an exam, so if you can just do the range, you'll probably be all right, to be honest. But interquartile range is something that I would urge you to think about as well, because it might appear. So here's a chance to do that. Okay, and I've put the advice on how to calculate that on the screen still, but I've given you a set of numbers which I'd like you to try and use to work out your range firstly and interquartile range. All right, so have a go at doing this, and I'll reveal some answers in a minute. Okay, so I've ordered the numbers from lowest to highest. You can see there on the thing below. And what you can see now is there's my lowest, there's my highest. So my range is 50 minus 12, and therefore my range is 38. Okay, that should be easy. So hopefully you've got 38 as your range. When it comes to the interquartile range, it's an even number. So I've got two numbers in the middle, 26 and 27. So my median number is the mean of those two. So it's 26.5. Okay. Then my lower quartile is nice and evenly, so it's number 5, which is 22, and my upper quartile is 33. So to work out my interquartile range, I need to take away 22 from 33, and that gives me 11. Now there are a very big difference there, but we're eliminating those extreme results from our answer. So range, very easy, smallest take away from the biggest. Interquartile range, you need to do those little steps first to find the lowest quarter and the the upper quartile, and then you subtract one from the other, and that'll give you your interquartile range. Hopefully that's been fairly straightforward. Percentage increase and decrease. Now the steps that I use, okay, and this is for you if you don't use your if you want to use your maths teacher's one because you understand it, just ignore what I'm about to say, all right? But if you struggle, this might help you. This is just what I do. So, firstly, I subtract the first number from the second number that I want to try and work out from and to. Then I divide the difference by the first number again. So I take the first number from the second number, divide the difference by the first number, so whatever is left over, whatever difference is, divide that. Then I multiply it by 100 to get the percentage. Okay, 3 steps. Take the first number from the second, divide the difference by the first number again, and then multiply by 100. If your number has gone down from your first to the second, you do exactly the same, but you just have a negative number, and that negative number will show you a minus, so a percentage decrease. So it still works depending on whether your number's gone up or down, because it will show you an increase or decrease. Okay, so second minus first, divide by first times 100. That is the simplified equation that you could use to help you work it out. All right, that's what I do. If you do something different, then do that, and you understand it, then do that. Please don't just confuse yourself by adding an extra one in there. All right. So here we go. Here's an example. You've got populations projected in the UK, and if I was to follow those steps 1, 2, and 3, what numbers would I come up with? You can see that all of these go up except Northern Ireland, so you should see a percentage decrease for Northern Ireland. But try this technique and see what you get. Okay, I'm gonna stop talking. You pause the screen, and then I'm going to reveal the answers. When you're ready, unpause the screen, please. Okay, so what you should have got is that the UK's population is going to increase by 7.9%. England's will be going up by 9.7%. Wales 6.3%. Scotland by 5.5%, and because we've got a minus figure, Northern Ireland is going to be going down by 5.3%. Okay, so that is what you should have got with regards to percentage increase and decrease. Okay, that really is all the geographical skills you're going to need to know and should equip you fully for anything you're going to be faced throughout all of papers 1, 2 and 3. So please make sure you've gone over these, and if there's anything you're not sure about, please, as ever, email me or come and see me in person or your teacher, and hopefully we'll be able to clarify with you what it is you need to do and how we can help support you in any way we can. All right, but thank you very much for listening, and I will see you next time.